Hi guys, welcome to another maths tutorial brought to you by Dialect Tutoring. Today we're going to have a look at the 2019 National 5 past paper. Here we're going to look at the full working solutions for the entire paper. We do have subsequent videos on the other years, so be sure to check them out as well. So if we take a look at question number 1, then the paper is worth 50 marks. So it's not as big as the second paper, which I'll put a link in the description to that once the video is out. But here question number 1 is on functions. So the question here says that we are given a function f of x is equal to 5x to the power 3, and we need to evaluate f to the minus 2. So what that means is that f of x, if that equals 5x cubed, then here in the function we've replaced x with minus 2. So that means in the right hand side of the function, wherever we have an x, we replace with minus 2. So f of minus 2 is equal to 5 times minus 2 cubed. Now minus 2 cubed is minus 2 times minus 2, so that minus 2 times minus 2 is equal to plus 4 multiplied by another minus 2. So that gives us minus 8. So what we now have is 5 multiplied by minus 8. So 5 times minus 8 will give us minus 40. And that's how you would go about finding the value of f of minus 2. Now question number 2 is we have to evaluate these two fractions and we need to give them our simplest form. So the first thing that we'll do is we'll convert this to a top-heavy fraction. That way we can combine the two of them together. So here we'll have 3 over 8 times, and then to convert this to a top-heavy fraction we do 1 multiplied by 7 plus 5. So that will give us 12 over 7. Now when you multiply fractions together, you simply times the two tops and times the two bottoms. You don't need to make a common denominator on the bottom. So the first thing that we'll do is we will have 3 times 12, so that will give us 36, divided by, now 8 times 7 will give us 56. So we can divide these by 4 on the top and the bottom. So that will give us, in our simplest form, 9 over 14. And that's how we go about solving that simple question there. Now question number 3 is expanding some brackets. Now we have to be careful here in that we have a bracket with 2 terms multiplied by a bracket with 3 terms. So what we can't do is use FOIL. So what we have to do is take one term at a time and multiply it by the bracket with 3 terms. So here what we'll do is we'll have x multiplied by, and then the 2x squared minus 7x minus 3, then it's plus, this comes from this plus, 5, and then 5 multiplied by this bracket here, so that'd be 2x cubed, squared, minus 7x minus 3. So then all we do is we multiply out the brackets, and then we'll collect the like terms. So we'll have 2x squared times x, which will give you 2x cubed, minus x times 7x is 7x squared, minus 3 times x is minus 3x, plus 5 times 2x squared, which will be 10x squared, then plus 5 times minus 7x will give us minus 35x, and then 5 times minus 3 will give us minus 15. So then all we have to do now is just collect the like terms. So here we have 2x cubed, we don't have any other x cubed, so that's that one done. So we tick that one off. Then we look at the x squared and we see we've got minus 7x squared plus 10x squared. So that means we'll have plus 3x squared. So we can tick them off. Then we have minus 3x minus another 35x, which will give us minus 38x. And then the 15, we have no other number by itself, so that would be minus 15. And that's how you would go about solving that kind of question there. Now, question number 4 is a arcs and sectors problem. Here it gives us a diagram of a sector of a circle with centre C. And it tells us that the radius here is 30 centimetres, and we need to calculate the length of the major arc AB. So that means it's going to be this whole, if I can draw it properly, this whole length here, so from A all the way around to B. Now, because this is a non-calculator paper, we have to take pi as 3.14. And we just need to be a wee bit careful when it comes to the multiplications. Obviously, we don't have a calculator, so we have to take it each step at a time. So the first thing that we'll do is we'll write the formula for the arc length. So we'll put arc length is equal to, it's your angle divided by 360 times by pi times by the diameter. Because your arc length is, say, in centimetres. So if we put r squared, we would be in centimetres squared, so we'd then be working with an area. Here we're only wanting the length. Now our angle is 240, so it's going to be 240 divided by 360 times by 3.14 times by, now the radius is 30, so our diameter is of course going to be 60. So now we just need to start to simplify this. So the first thing we could do here is we could knock off the two zeros. So we'd end up with 24 over 36. Then that would be times 3.14 times 60. Now if we do 24 divided by 36, that will give us a value of 2 over 3. Then we go times. Now what I'm going to do is I'm going to look at this bit here separately first. So the way I'm going to do this is I'm going to do 60 and multiply it by the 3.14 first. Now what I mean by that is I'm going to change the colour here, and we'll change it to green, is 60 is a multiple of 6 times 10. That will of course give you 60. So what I'm going to do here is I'm going to multiply the 3.14 by 10 first. So 3.14 times 10 will give us 31.4. Now I'm going to times that by 6. Now be sure to make sure that your decimal point doesn't change. So 6 times 4 will give us 24. Then 6 times 1 is 6 plus 2 is 8. And then 3 times 6 will give you 18. So this value is 188.4. So then what we do is we have 188.4. And then what we can do is we can have 2 over 3 multiplied by 188.4. So again what you could do is you could put that over 1 and then times the two tops times the two bottoms. So if we do 188.4 times 2, that's going to give us 376.8. Then we divide that by 3. So then at the side you could do your chimney sum, and then what you will find is that when you divide these two numbers together, your final answer will become 125.6 centimetres. And that's how you would go about solving that kind of problem there. So question number 5 is a statistics question asking us to find the median and the semi-interquartile range for a given set of temperatures that were recorded in Grantford over a 9-day period. So the first thing that we'll do in order to determine the median is we'll put these numbers in order, beginning from the lowest to the highest. So we can see that we've got two threes. So we'll put 3 and 3, so we can cross them off. Then we have 2 4s here, so we have 4 and 4, cross them off. Then we have 5, then we have a 6, then we have a 7, then we have a 9, score that, then we have a 9, and then we have a 10, so we'll score them out. So then all we have to do is just cancel out on different sides, so taking turns, so we cancel this, then that, this, then that, here, 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 and here. And that tells us that the median is 5. So right down here we can say that the median equals 5. So this has found the median. Now what we need to do is, this is our first quartile and this is our second quartile. So now we do the exact same thing, but we determine the median of each individual quartile. So again, we'll do the same thing, so we'll cross that out with that, and then we're midway between 3 and 4, so Q1 in this case is going to be 3.5, and then here we'll do the same thing, so 6 and 10, and then we're between 7 and 9, which means that Q2 is going to be equal to 8. And now what we can say is that the semi-interquartile range, so that is normally abbreviated to SIQR, is equal to a half multiplied by Q2 minus Q1. So we have a half multiplied by 8 minus 3.5. So if you perform that calculation, you will get a value of 2.25. And that is your semi-interquartile range. Now I'll just change this colour back to red, like so. Now part B says that over the same 9-day period, the midday temperatures in NDOC were also recorded. The median temperature was 8 degrees Celsius and the semi-interquartile range was only 1.5 degrees. And we need to make two valid comments comparing the midday temperatures. So the two valid comments are going to be comparing the median and then comparing the semi-interquartile range. So this is just to see if you know what these mean. Now if we look at the median first, if we compare the median, then we can see that the median for this place is 8 degrees, whereas the median for Gratford is only 5. So what we can say here is that on average, the temperatures, so the temperatures in Gratford, I'm just going to call that G, is lower. So in general, the temperatures are going to be lower in Gratford compared to NDOC. Now the temperatures in Gratford though are less consistent compared to NDOC because the semi-interquartile range is much higher. So remember, the semi-interquartile range is about the spread of the numbers. So we would say here that the temperature in Gratford is less consistent, i.e. they are slightly more over the place. So if we were to see the data for NDOC, we would see that there would be more consistency within these numbers. Now question number 6 is, it gives us the fuel consumption of a group of cars as recorded, and the scatter graph shows the relationship between the fuel consumption, which is F kilometres per litre, and the engine size, which is E in litres. And it asks us to find the equation of the line of best fit in terms of F and E, and we need to give the equation in its simplest form. So a lot of the time people will try and pick these values, or this dot here, or something else. But in order to use the equation of this line of best fit, we must use these 2 points that are located on the line. They must be on the line. So what we have here is we have 2 coordinates. So we'll call this coordinate A. This is going to be 1.5 and 14. So 1.5 and 14. And then B is going to be 3.5 and 8. So 3.5 and 8. Now the equation of the straight line should be in the form y equals mx plus c. However, we don't know where it cuts the y-axis. So we have to use the y minus b equals mx minus a formula. Now we need to know m before we do anything else. So right away we're going to work out what our gradient is, and I'll do this in a different colour. So m equals, now the formula for the gradient is y2 minus y1 over x2 minus x1. Now this is where we label, before you start to substitute in values, label your points first. So I'm going to make these the ones, so this will be x1, y1, and this will be x2, y2. So now we're going to have 8 minus 14. Now I've made this hard for myself, but you can do it the other way about. This just to let you see the hardest configuration for this. And then we have 3.5 minus 1.5. So 8 minus 14 is going to give us minus 6 divided by 2. So that means that our gradient here is minus 3. Now let's do a checklist, because we can see that this line has a negative slope. So we would expect a negative gradient. Now what we need to do is we need to then determine which point we're going to substitute in. Now you can pick either one, it doesn't matter. So here what we'll do is I'm going to pick point A. So this is going to be the A value and this is going to be the B value that we substitute in here. So we have y minus 14 equals minus 3 bracket 1.5, x minus 1.5. So we'll have y minus 14 is equal to minus 3x plus 4.5. And then what we do is we take the minus 14 across, that will go over as plus, so we get y equals minus 3x plus 18.5. And that is how you would go about solving that equation there. However, before we forget, the question asks in terms of f and e. So just now we only have 2 marks. So almost forgot is that we need to come up here and we see that y is f and x is e. So what we then do is we say that y, and that's going to be f equals minus 3 e plus 18.5. And that there is your final answer in terms of f and e. Now the question says, our car has an engine size of 1.1 litres. We need to use the equation from part A to estimate how many kilometres per litre he should expect. So I'll write out the formula that we just created. So it was f equals minus 3e plus 18.5. Now we want to know the kilometres per litre, so that's f. So we need to know the value of E, and remember E is the size of the engine. So we know the engine is 1.1. So we'll have F equals minus 3 bracket 1.1 plus 18.5. So F equals minus 3.3 plus 18.5. Or another way of saying that is 18.5 minus 3.3. That will give us 15.2. And that's how you would go about solving that question there. Now question 7 is a change in the subject of the formula. We have an equation for A. This is the area of a trapezium, and we need to change this to the equation for X. So first thing it'll do, I'm just going to change the colour back again. So I'm going to write out the equation. So 1 over 2h bracket x plus y. So the first thing that I'm going to do is I'm going to bring this 2 across to the other side, because that's dividing on that side. So if I take that across, it's going to go over as times. So that gives us 2a equals h bracket x plus y. Now I then want to get rid of the h. So h is multiplying this bracket, so I'm going to have to divide both sides by h. So we then get 2a over h equals, let's make that an h, x plus y. Now we're almost there, we just need to take this y across. So y is plus on this side, so it's going to go over as minus. So we have 2a over h minus y equals x. And again, you can rewrite that the other way. So if you prefer, you can have x equals 2a over h minus y. Both of them are the same. They are both acceptable. And that's how you go about changing the subject of that formula there. Now question 8 is a simultaneous equations question. So it says here that John bought 7 bags of cement and 3 bags of gravel, and the total weight of these bags was 215 kilograms. We need to write down an equation that illustrates this information. So I'm going to use cement, I'm going to call that C, and for gravel I'm going to call that G. You can call it anything that you want so long as you are consistent. So what I'm saying here is that 7 bags of cement, so 7C, plus 3 bags of gravel must equal 215. So that's the first mark. That's you created your first equation. The second equation is now that Shona has bought 5 bags of cement and 4 bags of gravel, and this weighs 200 kilograms. So again we'll have 5C plus 4G equals 200. And now we need to calculate the weight of 1 bag of cement and the weight of 1 bag of gravel. Now there are 2 possible ways of doing this. You can do simultaneous equations through substitution, or you can do them through elimination. Either or is acceptable. So what I'll do here is I'm going to do this in terms of elimination. So that's where you stack them on top of each other and then cancel terms out. So the equations, I'll just stack them here, is going to be 7C plus 3G equals 215, and then we have 5C plus 4G equals 200. Now I'm going to cancel out the C's, so I'm going to have to multiply this whole thing by 5 and then multiply this whole thing by 7. So again, you could cancel out the G's as well. It doesn't matter, you will always get the same answer regardless. So here we'll do 5 times 7, which is 35, so that's 35C plus 15G equals, now 215 times 5 will give us 1075. Then we'll have 35C plus, and then 4 times 7 will give us 28G, and then 7 times 200 will give us 1400. So now we have these the same, we can take the equations away from each other. Now I'm going to do the bottom equation, take away the top, just so that we can neglect any of the negative values. So 35 take away 35 is of course going to eliminate the C's, which is fine. Then the next equation is going to be the 28, so remember we're doing it from the bottom take away the top, is going to be the 28 minus the 15, so that will give us 13G, and then we'll do the 1400 minus the 1075, that will give us 325. Then we just need to divide 325 by 13, and when you do that, you will get a value of G to be 25. So we know that the weight of the gravel is 25 kilograms. Now all we have to do here is then take one of these equations, any one that you want, and multiply it, substitute in G, and rearrange for C. So this time I'm going to use this equation, so I'm going to have 5C plus 4G equals 200. Now 5C plus 4 times 25 equals 200. Now 5C, so if we do 4 times 25, that will give us 100, plus 100 equals 200. So we'll take that plus 100 across, so you get 5C will equal 100. So C will equal 20 kilograms. So we know that 1 bag of cement will equal 20 kilograms and 1 bag of gravel will equal 25. Now we have to communicate this in your final answer. So in order to get the 4 marks, we need to communicate it. So we say that cement will equal 20 kilograms, and then we'll say that gravel equals 25 kilograms. Just like that. And that's you just communicated your answer. So question number 9 gives us a parabola in which we have a maximum turning point of 420, and it asks us to write down the equation of the axis of symmetry. So the axis of symmetry is essentially where is the graph, if it cuts in half, where is it symmetrical? So it's symmetrical about this point here. So that equation for that straight line would just be x equals 4. And that is your axis of symmetry. So then part B is, it gives us the equation in the parabola in this form of y equals b minus x plus a squared. So the value of a is there's the same value of x, but the opposite sign. So it's what would make this bracket equal 0, i.e. if x is 4, a would have to be minus 4. So it's as simple as that, a is minus 4. And then b can be written directly as the y coordinate of the turning point. So b in this case is 20. So a nice easy 3 marks in the exam there. Now question 10 is a vectors question, and it says express PQ in component form. So we're given PR and we're given RQ. So we know that if we look at these different individual vectors, then what we can see is that PQ is going to be the combination of PR plus RQ. Because if we plus these, so say if we have PR is equal to R minus P, and then RQ is equal to Q minus R. So if we plus these together, watch what happens. So we would have R minus P plus Q minus R. The R's would cancel and we're left with minus P plus Q. Then we have PQ, which would be Q minus P. So that's how we know to add these together. So we simply add these two vectors. So we have 6 and 4, minus 4, plus minus 1 and 8. So 6 plus minus 1 is 5, and then minus 4 plus 8 is 4. So our vector of PQ is 5, 4. Now M is the midpoint of PR. So now what we have to say here is that we need to express MQ in component form. So there are 2 ways that we can go about this. For me, what I would say is we need to take the value of MQ. So MQ, we can either go this way and that way, or this way and that way. Either or is acceptable. So we'll go from PR. So MQ, let's write this out, is going to be a half multiplied by PR. That is a given, because that's our starting position. So regardless of what way we go, that's the way we have to go about it. So then what we'll do is we'll have a half PR, then we'll do plus RQ. So that means we're going from here to here to there. So we know that PR from the previous calculation was PR, where's PR? 6 minus 4, so that'd be 6 minus 4, plus, and then we know that RQ was the minus 1 and 8, so then we just do a half multiplied by 6 and 4, so that'll give us 3 and minus 2, plus then minus 1 and 8, so then that is going to give us a value of 2 and 6, and that is the vector for MQ. Now question 11 is Pam is designing a company logo, and she starts by drawing a regular pentagon, so it's given A, B, C, D, E, and the vertices of the pentagon lie on the circumference of a circle with centre O. She then adds the design as shown. And AF, so AF here is the diameter of the circle, and we need to calculate the size of the angle OFB. So OFB, so that's this value in here. So what we can see here is that if we look back at the pentagon, we know that all of these angles must be equal to each other because it's within 360 degrees. So if we do 360 divided by 5, we find out, oops, so I'll just change this, we find out that this angle in here is 72 degrees. Now that's helpful when if we were trying to work out all of these other angles, because essentially they're all identical, each triangle is the same. However, the issue lies now that we've added in this shape. So right away we can put in that this is 72. Now if this part here is 72, then if we consider this straight line, then we know that from that point there to that point there is 180. So to work out this angle, what we say is that we have 180 minus 72, that tells us that that is 108 degrees. So in there, this part is 108. Now next what we do is, this is an isosceles triangle. So if this is 72 degrees, then all we have to do is for each of these angles in here, we would just do 180 minus 72, and then for this angle in here only, we would divide it by 2. And that would tell us that this value is going to be 54. So in here, this is 54 degrees, which is fine. Now, you have to be very, very clever here and look out for the hidden trick. And it's the fact that this part here is a 90-degree angle. So now we know that's 54. If we do 90 minus 54, that will tell us the angle in here at B. So 90 minus 54 is 36 degrees. So now we know that this in here is 108. We know that this part here is 36. Then all we have to do is for OFB, so OFB, that part in there, we just say that OFB is going to be 180 minus 108 plus 36, and that'll tell us that that there is 36 degrees. Likewise, we can see that this is an isosceles triangle again, so we know that because these are equal to each other, if that's 36, that's got to be 36 as well. So both ways are acceptable. Question number 12 is a rationalizing a denominator, and this is a surds question. So we need to express root 2 over root 40 as a fraction with a rational denominator. So the first thing that I would do is, well, you can either simplify the root on the bottom first, or we can simplify the root when we get it on the top. So for me, I normally like to rationalise the denominator right away and then simplify the numerator as we go. So if we have root 2 over root 40, then all I'm going to do is times the top and the bottom by root 40. That way we will get rid of the square root sign on the bottom. That says rationalise the denominator. We have now got a rational number. So here we have root 2 times root 40 over 40. Now when we times surds, it's the values underneath the square root sign. So this becomes root 80 over 40. Now what we then have to do is simplify this root 80. Now in order to do that, we have to incorporate values that have their own complete square root sign. So what we'll do is we'll need to think of two numbers that will times together to give you 80, one of which has its complete square root. So we could try 16 times 5, because 16 is one of the values that has a complete square root, and that tells us that the 5 is the smallest value that we can get underneath the square root sign, so that helps us be in its simplest form. So now we have the square root of 16 times the square root of 5 over 40. So that means we have 4 root 5 over 40. Now we can then simplify the 4 and the 40, and that will give us root 5 over 10. And that is your final answer. Now question 13 is we have part of the graph of y equals 3 cos x plus 45. And it says the graph has a minimum turning point at A. and we need to state the coordinates of A. So the first thing that we need to do here is establish where everything has moved, because we need to compare essentially our graph to a standard cost graph. So a standard cost graph looks like that. So we have 1 and minus 1, and this would be at 180 and then so forth. So if we compare this to what we've got here, then we can see that the plus 45 has shunted the graph to the left by 45 degrees. And the 3 has stretched the graph by an amplitude of 3. So that means that this value is now minus 3. So that's the limits, that's because of this 3 here. So we now have the y coordinate for the graph, because we know the y coordinate now is minus 3. Now the only other thing we need to do is work out what our x coordinate is. So normally what we have is our graph would normally turn at 180. However, it's been moved to the left by 45 degrees. So we need to do 180 minus 45, which will tell us that this angle here is actually 135 degrees. So the coordinates of A is 135 and minus 3. And that's just based off of the comparison between the standard cost graph and the cost graph that it's gave us here. So question number 14 is a algebraic fractions question. Now we need to eliminate the fraction and try and get this into a linear equation and then try and solve for x. So the first thing that I would do here is I would just try and treat this all as a oneer. Sometimes it's good to separate them if the equations are quite complex, but here the equation is fairly simplistic. So what we need to do is we can remove this 2 and 5 if we multiply everything here by 2 first. That would cancel out this 2. So what we end up with is x minus 2 equals 2 bracket 3 minus x divided by 5. Then what we can do is we can multiply everything by 5. And then, so that entire thing by 5. That will cancel this 5 out. So here we get 5 bracket x minus 2 equals 2, 3 minus x. So then what we can do is just multiply these out. So we get 5x minus 10 equals 6 minus 2x. So now what we'll do is we'll take the minus 2x and we'll take that across to this side. So that'll be 5x minus 10. Now it's minus 2x on that side, so it'll go over as plus 2x, and that'll equal 6. So then 5x plus 2x is going to be 7x minus 10 equals 6. Now I'll take this plus 10 and it'll go over as minus. It'll go over as, so that's minus 10, it'll go over as plus. So 7x will equal 16. So then we need to divide both sides by 7 in order to get rid of the 7 on the x. So x equals 16 over 7. And that's how you would go about solving that equation there. And then finally, question 15 is there is a ball that's kicked from a cliff top, and the height h in meters of the ball relative to the cliff top after t seconds is given by this expression here. So we have h equals 12t minus 5t squared. And we need to calculate the height of the ball above the cliff top after 2 seconds. So all we need to do here, one mark, is we substitute in. So if t equals 2, we want to know the height. So we have the relationship, so we know that h equals 12t minus 5t squared. So substitute in t is 2. So we get 12 times 2 minus 5 times 2 squared. So h equals, that will be 24 minus, now 2 squared is 4, times 5 is 20. So h equals 4 meters. And remember, don't forget your units. Now part B says that the graph below represents the height meters of the ball relative to the cliff top. Yep, so the C is 17 meters below the cliff top. After how many seconds will the ball hit the C? So again, we'll have the equation as H equals, it was 12x minus 5t squared. Sorry, that's t. Try that again. So H equals 12t minus 5t squared. Now this time we know the height. Our target height is 17. However, we need to think about it relative to the ball. So our target isn't actually plus 17, it's actually minus 17 because that's the distance from here to here that the ball has to travel. And we need to work out the time to reach a height of minus 17 meters. So here what we'll do is we have minus 17 equals 12t minus 5t squared. Now, as it stands, that equation looks a bit different compared to what we're used to. However, if we play about with this, we will actually see that this is a relatively simple equation. So if we take everything here, the 12t and the minus 5t squared across to the other side, let's see what happens. So the minus 5t squared will go over as plus. So that'd be 5t squared minus 12t minus 17 equals 0. So now what we have is a quadratic equation. So we just solve this using the trinomial, or you can use the quadratic formula. However, I don't recommend using that at this stage because this is the last question and the quadratic formula would take a fair amount of time, and especially with some large numbers in there. So here what we'll do is we have 5t and t, so we need two terms that will times together to give you 5t squared. That'll be 5t and t. Now I have a full in-depth video on how to solve trinomials using this cross method, so be sure to check that video out. I'll put that in a link in the description just in case this isn't 100% the same way that you would do it. Now the left hand side of the cross corresponds to the left hand side of the brackets. So that means we're going to have 5t here and t here. Now we need two numbers that will times together to give you minus 17, but add together to give you minus 12. Now 17 is a prime number, so we can only use 17 and 1. And we're going to use minus 17 and we're going to use plus 1. It just means we have to be very careful as to where we put them. Now here I'm going to put the minus 17 here, I'm going to put the plus 1 here. And this acts as a calculator. So you start off at the 5t and multiply down the line. So you have 5t times 1, and then you'll have plus, and then it will be t times minus 17. Because t follow the line times minus 17. So we have 5t minus 17t, which gives us minus 12t. That is what we need. That's our target value. So that means that this is our first bracket, and this is our second bracket. So we have 5t minus 17, or t plus 1. Now how do we know which one is correct? So what we have to do is split these in half, and do 5t minus 17 equals 0, or t plus 1 equals 0. Now that would mean that t would be equal to 17 over 5, or t would be equal to minus 1. Now t is time, so you can't have negative time. So therefore that one is wrong, and the time it takes is 17 over 5 seconds. And that's how you would go about solving that question there. Now that is the end of this past paper, so paper 1 is now complete. Hopefully this was helpful in understanding how to solve these exam style questions. I'll put a link in the description to the next video that comes up. If you like this video, please like and subscribe to the channel. It really helps us reach as many students as possible. Thank you for your time, and we hope to see you in another video.